Hello, everyone. Okay, so for this next section, it says solve for the indicated angle. So I do want you to remember that for angles, we're going to be using inverse trig. And so inverse sine, inverse cosine, inverse tangent. And we're going to be rounding these angles to the nearest degree. So what does nearest degree mean? The nearest degree just means to the nearest whole number for these angles. Okay, so the first thing I'm going to do for every single one of these, we know that the Greek letter theta typically represents an angle. So I'm just going to go put a theta on every single one of these where there's a variable. If it doesn't already have one there, that just reminds me, hey, I need to use some inverse trig. That's what I'm looking for every single time. So now we just have to figure out, is it inverse sine, inverse cosine, or inverse tangent? So just like we did before, we're going to look and see what pieces I have. So 12 is going to be opposite, while 15 is going to be, let's be careful here, 15 is going to be adjacent. Adjacent. We do not have the hypotenuse there. The hypotenuse is blank. So what goes with opposite and adjacent? We know that that's going to be some inverse tangent. So this angle, theta, is going to be equal to the inverse tangent of its opposite over its adjacent. So that's going to be 12 over 15, not 15 over 12. And so let me see if I can grab a calculator real quick just for people who need this explanation. Okay, so when I'm typing this in, when I'm using this calculator, to get inverse tangent to pop up, this is our tangent button right here, obviously, but written in light blue above it is inverse tangent. So that's that's the button you're going to use for when you're finding angles. That's written in light blue, so we have to click second first. So when you click second and then you click tangent, what's going to pop up is this already ready for you with an open parenthesis. So then you're just going to tell it what was its opposite piece over what was its adjacent piece. So 12 divided by 15. If this is a decimal, you have to use the division symbol. If not, you could use that fraction symbol. If you've been using this A and B over C button, that's totally fine. The only thing that's not going to work for it is when it's not a ratio of whole numbers. Okay, so you'd click enter and let's see exactly what would pop up. Get rid of this thing. When I type that in, I'm typing it in literally to what you just saw on the screen. I have that exact same calculator. Second tangent of 12 divided by 15. If you have a different calculator and you need help with that, just come see me. I am happy to help you. It is my job to help you, and I enjoy helping you. So let's not even say about. Let's say exactly what it's equal to on the calculator. 38.6598 ... Okay? So to the nearest degree, that's going to be to the one spot right here. Okay, so what is the digit I'm looking at? 8. What tells it whether it should stay at 38 degrees or round up to a 39? This 6. So is 38.6598 closer to 38 or closer to 39? The 6 tells us that it's closer to 39. So we're going to say that this is about 39 degrees. I do want you to make sure that that makes sense as an answer. Is it an acute angle like I expected it to be? And yes, it is. Okay? So let's just keep doing that. Only thing that's going to change is that I'm going to have different pieces. I'm going to be using different inverse trig functions. So from theta, we have our opposite on this one and our hypotenuse. Of course, that what goes with opposite and hypotenuse, that's going to be my inverse sine. So theta is going to be equal to my inverse sine of opposite over hypotenuse. So the denominator should be bigger on this one since the hypotenuse is always bigger. So I'm going to type that in. Second sine, 24 divided by 25. What pops up exactly, since my students are working on rounding? 73.7397 ... Okay, so we're just trying to see, should I leave this at 73 degrees or should I round it up to 74? The 7 tells me, the 0.7 tells me to round it up to 74 degrees. Does that make sense as an answer? Is that an acute angle? It is. This one's the hardest to see for some reason. We always want to go grab the opposite and it's not there and it makes people uncomfortable. That just tells me that this is going to be the crocodile's mouth problem. Crocodile reminds me of cosine. So that's where these rays or these sides that surround these angles are the adjacent and the hypotenuse. This one's the adjacent because it's shorter. This one's the hypotenuse. It's across from the right angle. So that's going to be some inverse cosine. So this angle is going to be equal to the inverse cosine of adjacent over hypotenuse. Again, that denominator should be bigger since it's the hypotenuse. So you're going to type that directly into your calculator. Second cosine, 48 divided by 60. And you're going to get, let's see, 36.8698 ... So should I leave this at 36 or should I round it up to 37? This tells me I'm closer to 37 degrees. The 8 tells me I'm closer to 37 degrees than I am to 36 degrees. So the nearest degree, that's about 37 degrees. Okay, so we've done an example of each. An example of tangent, an example of sine, and an example of cosine. So I'm going to keep going on these, especially if you need help with this. You can keep watching, but if not, you can always skip ahead to the videos that you need. Okay, So from here, this is my opposite. This is my hypotenuse. So that's going to be some inverse sine. Theta is going to be equal to, you don't have to write that part out unless you want to, the inverse sine of 13 over 17. So when I type that in, inverse sine, 13 divided by 17, that is going to go, ooh, this one's a good one. I'm going to write this out. I was going to start skipping ahead, but 49.88 ... Okay, so who tells the 49 whether it should stay 49 degrees when I rounded or round up to 50? It's going to be the 8. So this is going to be approximately 50 degrees. This is approximately 50 degrees. That does make sense as an answer because it's an acute angle. Okay, all right, let's keep going. We've got our 17 is our opposite. 11 is our adjacent. That's the legs of the right triangle. Y'all are good at seeing this one. So theta is going to be equal to the inverse tangent. Just make sure it's opposite over adjacent and not adjacent over opposite. So inverse tangent of 17 divided by 11, that is going to be 57.094 ... And so that's going to be, this 0 tells this to stay at about 57 degrees. About 57. Okay. All right, and then this one, again, this is a crocodile's mouth. You can kind of see it frames this 9 and this 20 frame that angle. And so that's going to be my adjacent and my hypotenuse, because my opposite is not listed. That is going to be some inverse cosine of adjacent, the smaller piece, oh goodness, the smaller piece, 9 over the hypotenuse, 20. So that is what theta is going to be equal to. Inverse cosine of 9 divided by 20, and that is going to give me 63.256. So is this going to stay at 63 degrees, or do I need to round it up to 64? Well, the 2 tells me that it's closer to 63 degrees than it is to 64. So I'm going to round that to about 63 degrees, and make sure you check that and make sure it makes sense in regards to what I'm doing in the problem, and it does. So that's a whole section of inverse trig. We knew it was inverse trig because we are solving for angles, and we rounded those to the nearest degree per the directions.